So thank you and good afternoon. I feel like one of those people, when you go to dinner parties, you realize you're the second person who got invited. I don't think that's quite what happened here, but it feels a bit like that. But no, so within Accenture, I have the opportunity to work with clients all around the world in real-time systems and real-time data. OSIsoft has essentially a 40% market share across all of the industries. So quite frankly, a lot of my time is spent working with Pi and the Pi infrastructure. And so today I'm going to talk about some user stories. I will talk a little bit about some architectures. I know the previous speakers also had architectures, but I think it's quite good to get different perspectives of some of these ways of thinking about building Pi-based solutions. And then pretty much to focus on value. And so why don't we start there and start with some stories. And I'll start with 3 stories about driving value from Pi or from operational analytics, real-time and time series data. The first story is an energy-intensive company, very complex, lots and lots of different drivers, particularly around availability, quality of their product. But energy is an important element. They're highly energy intensive. And so they had Pi, and they had actually data lakes as well, and I'll come to those a bit later. They had lots of analytics, lots of reports, and they had 0 value. In other words, their energy usage was not going down. We were asked to come in and have a look at that. And I looked at all these 200 reports or whatever, and these graphs, etc., and sort of worked out, how do we make a difference here? And so we thought, we'll create this very simple graph. And this is actually, in fact, this is a copy of the slide I eventually showed to the directors. And it's a simple one. It's just energy by volume for different volumes. And what it shows is for any particular daily volume, you can either produce it using this amount of energy or this amount of energy. There's a scatter. They said, yep, agree with the graph. That's why it's so difficult. Lots of technical constraints, the environment. That's why we have a problem. I said, that's very interesting. Because if you then filter on that graph for different combinations of constraints or different environmental conditions, you see the variation is this much. So this variation is down to behavior. And if it's down to behavior, you can do something about it. And so what we did is we created some very simple screens, which was basically reinforced what was good behavior, i.e. less energy, etc. And within, about 6 weeks, we reduced their overall production energy by 10%, which for that company, as a large company, was quite a lot of money and was very fast. So the first lesson, I suppose, is actually, yes, it's great to have lots of data and to get value out of data, of course, but you have to look at what's the simplification and what's the thing that's going to make action and drive a difference, because that's actually where the value comes from. It's not the data, it's from doing something with it. Second example. This is a power generation company. They have a widget that gradually degrades, and it's a bit bigger than that, actually. It's quite large. And what it means is that at certain times you have to do an outage to go and do some very critical maintenance on that. But of course, if you do an outage and a shutdown, then you're not making money because you're not generating. So it's always a balance between waiting till as long as possible before you actually shut down and do that outage. But the trouble is, it's non-linear. It looks a little linear here, but it's actually quite non-linear. So it's difficult to plan ahead and work out when you should do the shutdown. So basically what we did is take Pi data, combine it with some simple models, and create forward predictions of when you best need to do that maintenance. And with those, they then are able to make sure that they're actually doing the maintenance at the right time. Now, the lesson for that is they've had other models. This worked because there was trust in the data, trust in the model. So the second key thing after simplification and action is actually to work with trusted data. Because if you don't trust the information, you're not going to do something with it. Third story. So So this is now a water company. Water companies, or water and waste companies, are allowed to pollute, okay, for particular reasons. For instance, if there's a lot of rain, and I come from Britain, so there's a lot of rain in Britain. If there's a lot of rain, then quite frankly, the infrastructure is such that you have too much volume. So the volume spills, it's called a spill, and with it comes the sewer as well, but it's been very diluted. So quite frankly, it's almost like water. So that's fine, it's designed to do that. But of course, the same infrastructure sometimes goes wrong and sometimes spills, so you detect that. So they have systems, and they had Pi, for instance, and the very first graph at the top is just a part of one of the graphs, is that they have a detector, which is every time it spills, it just detects. That particular site of that graph it spilled about 1,000 times in a year. So it had 1,000 of these little spikes. Some of those spikes are because a spill might sort of is a lip, some water drips over, and then a bit later, drips, drip. That's a spike each time. So they'd initially set that up with notifications. Oh, that's a good idea. We'll have notifications every time and they got 1,000 notification times their 900 sites, so they got a lot of notifications, and they couldn't do anything with it. Plus also they had to analyze and actually go back to the regulator to tell them whether it was a good spill or a bad spill. In other words, am I allowed to do it or not? Okay. So they had a team of something like 20 people working continuously all year, just doing this manual analysis. So all we did is we took that information, combined it with other measures like is it raining, what's the overall flow rates, etc., etc., and also used event frames, so we can combine those to say, right, is there a spill event happening? Also, what is the confidence level that this is a bad spill versus a good spill with some relatively simple rules? So now for that one site, they went from 1,000 events down to about 25 a year, okay? And some of them are good, some of them are bad, some they had to report and so forth. But the interesting thing also, as well as just the fact that they now had a much smaller group of data to go and to analyze and to report back to the regulator, is these events now are longer. And so now if you start to notify for something that might go on for several hours, you can send a notification. It's all one event. It's worthwhile to send a maintenance crew out to go and do whatever corrective action is required. And now you're starting to reduce the overall impact of those events. So now they're moving from, if you like, doing regulatory compliance, 20 people running around each year, just spending all their time trying to create some reports, some excuses about why that shouldn't look as bad as it does, to actually becoming a much more proactive and efficient and effective water company in terms of action. So what that's around is actually using the power of the different combinations of data and using that to change to a new way of working, a more proactive way of working. So there's a number of themes, and these themes I'm going to come back to later in terms of the overall story of getting value out of Pi and time series data. Now, there are three stories, and often we're asked by clients to say, well, okay, but, there's almost an infinite number of things that we could focus on. So how do you think about value? How should we think about value and over across the whole landscape of ideas? So this is a very useful framework to think of. The three stories I've put up there. So, thinking about in terms of improving performance, about improving resilience, in this case, resilience of assets, compliance and reporting, compliance against, in this case, environmental health or spill monitoring. And then the fourth I didn't refer to, but is also planning. And those can be done against the dimensions, production, asset, and quality, and so forth, and also down to interesting capital projects, which I'll come to a bit later. So this is a very useful approach where you can just sort of, if you imagine, to just do brainstorming at the intersects between this matrix and say, right, come up with an idea or two ideas per box and then use that to drive value. Now, being the sort of consulting company we are, we can survey all of our clients and other companies around the various industries and get ideas of where they're getting value. So the landscape, if you like, is that graph, is the framework. and then the spikes show where the main ideas are. Now you'll see on there a whole bunch of things that are sort of obvious really, reducing emissions, reducing energy, improving production volumes and so forth. Just a couple just to pull out. Limb sampling, for instance. I know some of you do that, but it's an increasing trend that I think we should think about, is that sample data is actually time series data. It's about taking a value, maybe it's a manually acquired value, but taking value at a point in time. Over time, if you store a series of those, you can start to build views and patterns about actually your product development and product quality, or the batch quality and so forth. The second one to call out is in commissioning. And I'm getting involved in a lot of more new construction. And quite often what happens is you put all the concrete there, the steel, you build the sites and so forth. And then eventually you commission it, and then eventually you're about to go to operate, and they say, right, we'll put in Pi now, or whatever real-time systems, right? It's very common. It's a bit like also when you do IT systems, the last thing you do is you put in reporting at the end, all right? So what they're learning is that actually if you bring in the real-time data earlier on in the process, it's going to be absolutely invaluable to drive performance, yes, through the construction phase and commissioning. It's clearly important to be able to measure and verify that your equipment's fit for purpose. But also, more importantly, is you're creating a baseline model for what the plant can look like at the extremes of the operating envelope. Because once your plant is live, you want it to sit there and be boring and just sort of do, keeps constant, yeah? In commissioning, you've probably excited it and used it at all of the boundaries. So now you've got some real data for the plant about what this could operate like at the boundary of the operating envelope. And therefore, it can become the basis for digital twins and artificial intelligence, machine learning, and so forth. So this is a very important trend that typically we're not seeing yet, but we'll see increasingly over time. Okay, so driving value. This graph is about the secret to driving value. And I'll let you look at it first of all. It looks a bit as though it's like mirror image, isn't it? Yeah. But actually the way to read it is from right to left. Because actually it doesn't start with the data, it starts with the outcome. Being absolutely clear what is the outcome you're trying to achieve. So I'll give you an example. I'd like to reduce my maintenance budget by 30%, whatever it is, right? Okay, that's a clear outcome. So the next question you ask is, what are the actions that are going to drive that outcome? What are the actions, the behaviors that you want to be different? So in this case, maintenance, wasn't it? So I want to do less maintenance, but also if something's about to break, I'd like to know about it so I can correct it before it breaks, right? So I do less maintenance if it's happy and got no problems, and I want to just do the right maintenance when it's about to break. Okay, that's fine, that's some actions. So therefore, what are the insights that will drive those actions? Those first three things, the good news is they're not technical at all. They're sort of things that often the people I deal with, like the CFO, are there any CFOs in the room? Probably not. So I can be rude about CFOs. But non-technical people who actually have the money, yeah, and actually are trying to say, please, I don't understand all of this stuff, what you're asking for. If you can go to them with a story and say, right, actually, the outcome is this is what we get to the value, these are the actions we're going to drive, and these are the insights that are going to drive those actions. And that's the reason why we want this business case. Then you're on quite a good step along the path of driving and getting the project off the ground. So often we'll do actually workshops, and that's all we do. So we want to talk about Pi or real-time systems. We want to do a data workshop, and we'll agree to do it, and we'll come in. And then the first thing we do is get loads of post-its and say, right, we're going to talk about outcome, action, insight. After the first 2 minutes, where they're a bit worried that they've paid you, lots of money. Actually, normally it's free when those workshops. But you've got your for false appearances. But but basically, after a bit, they suddenly realise, oh my God, we've got now 20 ideas, of valuable ideas, which are going to lead to a difference. impactful. Of course, at the end of the day, you then do need to worry about the data and the calculations which are going to create the insights. But you can focus on the right ones, which are going to create the right insights, and therefore you know it's probably going to be successful and there'll be a business case. So let's have a little bit about data and calculations. So this is the Simon Coombs view on architecture models on IT-OT convergence. I link it to the ISA 95 model. Part of the reason I do it, it's quite a nice model. It's the 4 layers from business down through optimization, through automation, through control, and layer 0 is the actual plant itself and the sensors. It's a well-known model. Has an advantage actually that most vendors actually know about it as well, and it's often a common language. So it's a good model. Slight change, and I'll show you what the change is that I've adapted it. But basically, on the top left-hand corner are the IT systems. This is how I get my own back on all my colleagues. For years, they always used to have about 200 boxes to describe IT, and sometimes they'd have an arrow or just a little box saying automation, C&I. So this is the opposite. Down on this side is the OT, or the operational technology, the automation landscape. A few years ago, I drew this as a joke for one of my clients. I said, I had to go and see him, moderately senior. I said, I'll just draw a funny picture of how bad your OT landscape was. It sort of backfired on me because he looked at it and said, yeah, that's quite a fair representation, actually. Yep, I agree with that. So I've kept it. I've shown it to many clients, and they do agree that this is relatively truthful. Because basically, the OT environment is complicated. It is very fragmented often. It's got lots going on. They often have a bucket, and it's often pi, and I call it a bucket. It's a bucket of data. They bung in all of the real-time data, okay, time series. They have 10 years or 20 years of time series data, and they have a mechanism for seeing graphs. So you can draw a graph and say, look at this, look at these lovely graphs that we have. And then you ask who uses them. And actually, to be fair, lots of people do use them and get value, but it's hard work. It's a lot of hard work. So this is often the starting point. And the starting point from actually driving this optimization and closing the optimization gap. Now, I said we varied the ISA 95 model. Basically, on the left-hand side, we've got sort of years and months, things which are long-term. So, ERP system, financial system is about annual budgets and quarterly budgets and so forth. And then on the right-hand side, minutes and seconds. So this is the real-time data. At the moment, I think the biggest value for clients is around optimization on day-to-day optimization. In fact, getting value from day-to-day, doing something different day-to-day. Yeah? It's not about necessarily at the moment trying to do something in milliseconds and become a glorified control system. And it's certainly not about taking a year of offline data and then coming up with a capital projects decision. Right? It's about day-to-day optimization. So that is what we're trying to tackle with this real-time analytics. And the first thing you do is you build a trusted data layer. Okay? Because remember, as I said in the second story, if you don't have trust, nobody's going to do anything with these insights. However good the insights are, they'll find excuses to not work. And so the way we do trust is we still have pi, still have the bucket, but we put alongside it the context, the AF. We put around it data quality management and master data management, so that you have a view of this time series the layer of data which is trusted. Now, AF, actually interesting, we'll do a survey then. Who's a Pi user? A company is a Pi user, yeah? Just to check. It is a Pi conference, but so all right. So probably about 3/4 of you. The others are presumably in the wrong conference, or maybe you want to become a future one. Okay, so of the 3/4 then, who actively uses within the company AF? All right, that's quite good, actually about half. Okay, so that's better than normal. Normally when I do it, it's normally like a 25%, a quarter. So I'm obviously preaching to the converted here. But what we find is actually you've bought AF, already in the license. It's there. But so many companies aren't actually using it effectively. I was talking to one client and the Pi team, and they said the reason they don't use AF is the IT department had locked down the AF server, so they weren't allowed to actually access it because it was, I don't know, for some constraint reason or whatever. It's like crazy. Because actually Pi and AF together is absolutely crucial to building the context of this data, this trusted data. An example of, I've used context quite a lot. If I say something is 37 degrees Celsius, okay, is that good or bad? No idea, right? If I said it was a boiler, which has been reducing down into about room temperature, then you say, well, okay, that's probably good. I probably can do some maintenance on it. If I said it was a refrigerator with some food in it and it's now at 37 degrees, that's probably bad, and you probably have to chuck out all the food, all right? So the context is really important. So it is sort of crazy that people should think that you can take this bucket of pie and then do something with it without knowing the context. So what we do build up is basically this trusted data layer. And together with that technology, put in the operating models to make sure that it actually remains trusted. And that's really crucial. So it's not just technology, it's about people and technology, which is a bit of a theme for this conference. And the top of that list, data chain governance, just a few words on that. If it was a billing system, you can have a functional responsibility for data. So I might be head of billing and customer, and so I'm now accountable for the quality of all of the customer information. That's possible, very common. But if I'm building these type of solutions, I've actually got to be responsible from right down from here, the sensors, which might be replaced randomly by a maintenance group with maybe a better sensor, but with a different constant. A control loop, which actually behaves differently, through to an acquisition system, through a bunch of reports might be different, and then finally the overall analytics. So each of those are probably involving a whole series of different parts of the organization. So what's really important, that's a chain of data, is actually to work out who is going to be accountable for ensuring that chain remains consistent and usable. So it's really key. But of course, on its own, it doesn't do anything. So you have to turn it into action. But that becomes really simple because you trust the data, you should do some analytics on it, make sure it's visible, create some notifications, and as long as you're involving some people who are actually going to become proactive and are rewarded for doing the right thing, then you're going to drive the change. So that becomes the simple model of turning insight into action. Now, I was asked to briefly talk about the business case, and I clearly haven't got time to tell you everything about writing business cases. But I thought I'd just put some thoughts to driving the business case for this. Obviously, a business case is around benefits and cost. Hopefully, the benefits are worthwhile versus the cost. The first thing, actually, if you look at the benefits, is actually to say, is there a strategic vision and to do it at scale? I'm involved in a lot of digital projects. The digital mantra now is that you should have a 10 times return on investment, right? It should be tenfold. It's not like a 10% improvement or whatever. It's like 10 times at least, minimum, okay? And it should be at scale. Last year I had the opportunity to be part of the Enterprise Agreement EA sort of seminar, and it was fascinating listening to the stories that these companies who'd had a vision to say, yeah, let us go and do Pi, big scale, and they were getting numbers like, 100 million, blah, 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 each year benefits, all right? So with scale came actually the scale of the benefits. They had an overall vision for driving that. On the other hand, I was talking to a client, and they'd created a data lake. They're very proud. They said, yeah, we've done a POC. It's worked incredibly well. And I said, oh, that's very, very interesting. How many tags? I knew it was time series. How many tags does that involve? They said, 2 tags. 2. I was thinking, right, okay, I could have done it on an Excel spreadsheet or something like that. And the point is, that company is still sitting there, not getting the value, in fact, actually, because they didn't have the ambition, didn't have the vision. And with that, didn't have the senior, if you like, sponsorship. Of like, this needs to happen, needs to be driven. So that's number one. Secondly, you have to also decide why you're doing it. So maybe you're doing it for surveillance. Maybe it is just to provide an overall view of the world. or maybe to be proactive. My definition of proactive is something maybe breaks, but you sort it out quickly within the day, and therefore it doesn't really matter that it broke. In fact, actually, it's a good business decision. You keep running it until it breaks, you quickly change it. Hey, everybody's happy because you've got redundancy or whatever, so it doesn't really matter. Prediction is actually preventing something happening in the first place. More complicated, may not actually be necessary. We had an oil and gas company that put all their assets in sequence from the most critical failure to the least. And what's interesting, I had a sort of graph like this. This tail, they realized if something broke, it didn't matter. But actually, by focusing and proactively improving that, they got a 25% return on their just on the value. They took out, if you like, 20%, 25% of their value just by focusing on the tail. So there's some, definitely proactive can be as good as others. But at the end of the day, it's also about actually doing something different, which is really around the behaviors and so forth. So that's on the benefit side. On the cost side, the point is actually build on what you've got. Yeah? So, think about, if you've got pie already, okay, then don't chuck that away or say, well, okay, well, what we do is clearly not working. I'm not getting value. I'll put a data lake on top of it. All right? Actually, how can you get that value from the pie? Obviously, there's some commercials, and there's a whole range of commercial models. And the point is, at the end of the day, though, the commercials will be just a way of getting the best approach or the most practical approach for getting that infrastructure. There's a whole range of models. But you have to be really clear about why you're doing it in the first place and not get too hot up about, I know salespeople, actually there's a few colleagues and things will be hot up about the commercial model, but actually it's actually more about what's the clarity around that relationship. But the important thing, though, in the budget is actually thinking how you're going to make sure this is actually usable. What's the operating model going to be alongside this investment in software or infrastructure so that actually you're using trusted data and you can be clear that you're going to continue to get the value. And as an example, Coombs, talked about them last year, but I thought I'd just use them as an example. They're a district heating company in France. The service we're providing Pi as a platform as a service, but bundled in to an overall platform of analytics and transformation. So it's a value-added relationship. In fact, actually, we're being paid, a proportion of what are being paid is based on the results, the outcome, the benefits. So moderately risky, but actually, with a focus, it focuses our mind and their mind on actually using this to drive the benefits. And lo and behold, actually the benefits they're getting is actually material improvements to the P&L. So that improvement in the P&L is actually what is leading to our revenues in this case. Physically, what we're doing is we're putting Pi up in the cloud and providing it as a platform as a service, coupled in with other analytics. And the interesting thing, though, is we're not using any other clever stuff. We've got manual logger, AF, event frames, Pi Vision, all of those elements coming together to actually drive material value within this district heating company. So it's an example of applying this infrastructure in a safe and secure way to drive value. Here's some screens. Screens on the left are the typical things you would expect. The ones on the right are actually all around making sure that this important mission-critical solution is operating. So the ones on the left are for the engineers to drive the value, various clever things they're doing there, efficiency. And on the right, this is about maintaining and ensuring the trust in the solution, because it's back to trust so they go and do something about that data. Now, that's the diagram I showed before. So that was where we got to in terms of the Pi landscape on-prem. Bit of a couple of last two slides on data lakes. Data lakes are great in the sense that advanced analytics, machine learning, all of that good stuff. There's some superb value that can be driven through that and using that in combination with prediction. However, just simply taking pi as a source of data and whacking all the data up into the data lake as fast as possible, or as slow as possible actually, or as slow as it happens, is not a good way to do it. Now obviously I'm speaking to a Pi conference, but I would say the same even in a data lake conference, or data swamp conference as they're sometimes called. What we would suggest is that actually if you're going to do that, you want to consider putting Pi and AF up alongside that data lake. Now, whether it's physically up there or whether it's just a connection, from on-prem to the cloud, that could be a debatable. We can debate that. But the whole point is that you're keeping with Pi and AF all the things that it's good at. It's good at storing and compressing data. It's good at actually giving a rolling 7-day average and giving you the answer and doing it very, very quickly. And actually just giving you that answer which is required, rather than actually sending terabytes of data up into the cloud for no apparent reason. It's also, once it's gone, I'll use this laser pointer. Once that data has gone somehow into the big data analytics, into the machine learning, the output for machine learning is often a time series index, a probability curve, a forward forecast or whatever. That's time series data. Store that back into Pi. If you come and see our booth, actually, which you'll see some examples of some future data, which is then can be compared against the actual data as it comes along. You can then use event frames and so forth to go and do added value and analytics. And so therefore you get this virtuous circle of improvements. So just to bring that home then. So just some thoughts. The advantages of applying Pi and AF rather than, say, data lakes. Number one, on average, it's a 75 times improvement in storage. The reason being is that actually, as you'll probably know from other conferences and presentations, Pi stores and compresses the data. Typically, it's 25 times improvement over, say, SQL. And in the cloud, basically, cloud solutions, data lakes work by having multiple copies. So essentially multiple copies of the equivalent of SQL. Could be Spark or Cassandra. But basically, with those multiple copies, you're creating, therefore, the 75 times. Yes, that's a cost of storage, but also it's actually a performance thing. You're moving data around that you shouldn't be needing to move. It's a performance just in terms of processing. And a cost in terms of the overall hardware, which can be absolutely significant. If you're comparing a little VM, a virtual machine for handling a few hundred gigabytes of data versus one that is sized, or normally a collection of them sized for terabytes of data. Coupled with that is actually out of the box, of course, you've got a whole bunch of standard solutions, which you wouldn't have in these more generic infrastructure. So, for instance, in Coriance, we have Azure. So that's the basis of the cloud basis of Microsoft. Some great tools there. We use Pi embedded, and so we get out of that the compression and the tool set built in to the whole Pi area. You've got the context and so forth, and you've also got some neat tools to actually be able to very quickly just go and create solutions for small visualizations and so forth. We saw some this morning in the keynote speeches where they were very quickly coming up with graphs, which you could then eventually, if you like, put into the wider data lake. So basically, a big, strong sort of message of actually building what you've got and getting the value out of Pi. So just in summary, therefore, value or transforming a new way of working. First of all, it's all about delivering the value. Remember, start from the outcomes and the actions before worrying about all the data and the calculations. And think about it as a new way of working and culture change. You have to build a trusted data layer, and that's absolutely crucial. And that's not just about the technical side, but also about actually providing things like data chain context and so forth, and governance. And then finally, think of Pi and AF as being a critical component for actually for managing the time series data within your organizations and working alongside even big data analytics solutions. So that was all I was going to say, so thank you. I think we have some time for questions, if there are any questions. Happy to take any. Yeah, there we go. Excellent. It's always fun when somebody asks a question.
So it seems to be a recurring theme to talk about taking your Pi data and not just sending it up to a data lake. Is that a recurring theme because a lot of people attempt that, or is that a recurring theme just to try and prevent people from doing that?
We're doing both.
Yeah.
Is that, yeah. So for both reasons, me and my colleagues, we're just as guilty as saying, data lakes really great, definitely apply them. And what tends to happen is that bit of the conversation gets remembered, and so everybody implements a data lake, and they say, right, now let's put all the data into it. And then once we put all the data in, then let's work out what we're going to do with it. And so they will remain nameless, but very large clients, that is typically the model. And they have, pretty much, I can't think of one that has actually managed to get value out of doing that at scale. Because basically, for all of those reasons I had previously about just the practical constraints from doing that. So for those clients, me and my team, we spend quite a lot of time coming up with migration paths of how you can then somehow retrofit back into Pi, because invariably they have Pi. Sometimes they have other products, and fine, you can do things with those as well. But generally, it's about unpicking where the analysis is. That's probably 2/3 of the time. For the other third, and for the new users who might be thinking about doing this, part of my message is, please think twice before going along that journey. Yeah. How many people have, just again, it would be useful, data lakes, yeah, there's one, definitely. But yeah, so data lake and then sort of caught a cold doing it and realized, oh, wait a minute, this is difficult, yeah? Yeah, quite a lot. Yeah, no, it's half hands going up. I can see you there, it's fine. All right, another question. Yeah.
Hello. We're being presenting those new technologies like cloud services. Are you going to update your architectures now with the new technologies? Right now you have Pi and AF in the cloud, I'm guessing on a Windows in the cloud machine, but now we're being presented with much more interesting ones in the conference.
Yeah, and I think they're for two different things. And I mean, obviously, I have to be careful because maybe I'm wrong, maybe whatever. I don't understand it sufficiently, or whatever. The way I see OCS is great, where you're moving to this, for instance, a community sharing and so forth of common data and so forth. The problem we're trying to solve here, which is at an enterprise level, is actually wanting to do machine learning and advanced analytics within a cloud environment. And so the cloud environment in this case maybe is Microsoft Azure, right? It's not a third-party separate environment. It's also a whole bunch of other components I want to use together with that. But I want a source of data. So in that case, what we're doing is we're mounting conventional, if you like, Pi and AF in that environment, okay? And then integrating it. That's where the value. OCS, I think, is tackling a different problem at this stage, all right? And so definitely has a place. If we go ahead 5 years, I'm sure the two will converge. Hopefully that's a political enough answer. Last question, and then one at the back. Sorry, Mickey, run around.
Being the devil's advocate here a bit, basically you're explaining us that the smartest architecture would be to introduce Pi in your enterprise architecture, and you're explaining to, well, we are at the Pi conference, so to Pi believers that Pi is the smartest solution. But why isn't the vendor landscape any broader than this, and why is the entire world, and looking from perhaps an IT perspective, why is the entire IT space looking into clouds and IoT and not in this element in the architecture?
Right, so you've combined lots of different components. A good question. So, two things. In this environment, I mean, I happen to use Pi, okay? But basically, you need somewhere a historian, and you need something that does the context, okay? Whether here or here, okay? Now, whether that's another vendor who has a historian and an asset model or equivalent, that's absolutely fine. I mean, as I said right at the beginning, if Pi has the 40% market share, that's partly because it's been around a long time, but partly because actually it is one of the highest performing and cost effective of those solutions for large scale, all right? So I've got no problem with, if I was asked advice, I'd probably use Pi by default, all right? But if for whatever reasons you don't want to use Pi, you definitely want to be using these sort of types of constructs of historian, compressed data, not tabular, uncompressed major storage issues and so forth, right? So that's the first point. The second is IoT is absolutely fine. I mean, this has got IoT, edge to cloud, right, devices. I haven't got drawn in there, but in effect, that dot, that's IoT. That's fine. You have any old sensors you like, okay? But what we're talking about is what you do it once you've actually got it up into the cloud environment. I'm sure, again, in 5 years, there will be, because the thing about digital is moving so quickly, there will be people who, of course, will look at this sort of stuff and say, I could copy that, yeah, and good luck to them, yeah. And we are starting to see some on the horizon, yeah. So it's more, I'm talking about an architecture view as opposed to necessarily say, yeah, there is only one vendor solution. Right, I think you're waving and saying it's the end of the time. Yes. Oh, one last question. There we go. One, very briefly, I can. You're waving at somebody, at a friend. All right. Okay, brilliant. Well, thank you very much for your time, and nice to speak to you.